Welcome to this afternoon panel here at Graph Connect. One of the amazing things that has blown me away about graph databases in Neo4j in the past, say, 12 to 18 months is the disproportionate amount of uptake that graph databases has versus a lot of other technologies, in particular databases, amongst the Global 2000. So amongst really big companies. There's a bunch of huge companies out there using graph databases for really mission critical things, which blows me away. We, about a year ago, we had a handful of Global 2000. Now we have over 20 Global 2000 using just Neo4j specifically, which is pretty extraordinary. Here we have a fine, young and awesome little collection of people who are from some of these Global 2000. So we have Sebastian Verheuge, from Telenor in Norway. Actually, I'm supposed to be able to pronounce your name. I apologize. And then we have Dominic Wagenknecht. Wow. Yeah, from Accenture. And we have Prem Malhotra from Cisco, all under the amazing guidance of Matt Aslett from the 451 group. So Matt, take it away.
Thanks, Emil, and thanks for handling the pronunciations. I was not looking forward to that.
Yeah.
So, thank you everybody for joining this session. So my name is Matt Aslett. I'm Research Manager for Data Management and Analytics at 451 Research. And I presented earlier, our perspective on the graph database adoption and some of the trends in the industry. And anyone who was in that session would know we had, some interesting questions at the end, specifically related to, customer adoption trends and specifically some of the potential issues that can happen at customer adoption and deployments. And I was helpfully able to bat some of those questions away and tell you to come to this panel where hopefully those will be answered. As Emil says, 3 very interesting projects. I think rather than jump between the 3, we'll start off speaking to each one about the project in detail, and then we can go into more sort of general questions, and then at that point, perhaps once we've heard everybody speak, open it up for more questions as well. So for start with Prem, since you're sitting right next to me, in terms of the project that you're involved with, could you just tell us a little bit more about the company, which I think people will know, but specifically your role within that company, and perhaps a little bit about the background, your background, and how you got involved in this.
Sure. So my name is Prem Malhotra. I work for Cisco Systems, and probably all of you know it's one of the large telecom collaboration space and data center space company. And what I do there is I work for the IT, and our job is to enable the business to run their systems faster and with agility. And I work for a master data management space. So over the last 5 years, we have evolved the master data to be at par with the best practitioners in the size of the companies that we work with, like Intel and Microsoft and so on. And the work that I'm going to describe to you is part of that MDM suite. So can I have the slides, please? I have a few slides to kind of go over, so it kind of gives you a good sense of it. And I can probably stand here or talk about it. So there are 3 components of the MDM space. One is the customer MDM, which is all the information about customer hierarchies, customer attributes, and so on. And what we have is a transactional MDM, which means it's not after the fact, it is while an application requires customer data, it kind of fetches it using the real-time calls. And if the new data needs to be created, it kind of gets done right on the fly. The other second part of MDM is the item information, which is all the products and services that Cisco sells. And again, a lot of attributes that go with it, which are attributes required for managing different business operations that happen along the Cisco's commerce platform. Now, these 2 were the beginning ones that are all based on the Oracle technologies, which we have enhanced. So no new 4J there. So the good question would be, why does the Oracle shop like Cisco go for a graph database out of nowhere? So the reason for that is the complexity of problem that a classic relational database has a hard time solving. And that's where the third one comes. And The third piece is in the domain called hierarchy management. So it's called hierarchy management platform. And the business problem that it addresses is that you have a bunch of hierarchies across finance systems, across the Cisco's businesses, which the way Cisco evolved so fast that they all kept in silos. So you often find hierarchies which look very similar. All they have differences is they have got different attributes, or their few nodes are different. Now the challenge is that each silo does do a good governance of its own information, but they're not talking to each other. So there's a lot of spreadsheet work going on when you have to connect or map different hierarchies together. So that slows down the business, and above all, there is no single source of truth. The core MDM principle is that you have a single source of truth that everybody, every application, every system is able to consume. That does not happen with these hierarchies. So though customer and item domains did keep a lot of key hierarchies there, which are all managed and available to everyone, the rest of the ecosystem did not have that capability. So what we looked at, some of the problems that happen when this occurs. One problem is when you have to allocate in the finance, you have to allocate the revenue allocations for different business groups to different product families. Now these allocations keep on changing year to year or every 6 months, and what finance does is, as a business, is a lot of spreadsheets keep going around. You can't go back in time. So time variance was a big thing. So if you all heard Rebecca's talk, there were two things that connect to what I'm going to tell you. One was the temporal aspect of data is very important for a big business, that there was no way to keep it. Second was there is a product hierarchy with product families and so on, and then there is this whole hierarchy about how Cisco is organized into business units. Business units have sub-business groups, and these also keep morphing over a period of 6 months, 1 year, and so on, and the companies that we acquire. And mapping the product families in terms of what revenue they need to bring in for each of these groups is a problem that was connecting two hierarchies together. There's no way to do it except on spreadsheets. So that problem basically slows down how fast can business in finance can do modeling of how to allocate different revenues for both internal reporting and for external reporting. Even that part is different, and being able to publish it to all downstream systems. So second problem that happens is in a large company like Cisco, you have HR hierarchy, which is all the people reporting to managers, and then you have projects which are funded by a department hierarchy. I think the slides are still not there, but I can just talk to them. So what happens there is I get to fund a project, but it is run by somebody else. So the team reports to another group. I have no visibility into the people who are working on that group and so on. So can you go up to the next slide? Yeah, out here. So this is the kind of picture that shows multiple problems. I just talked about one of them, which was the mapping of the hierarchies. But look at the bottom right. That's the one I'm talking about right now, where there's a need to map the HR hierarchy with the funding hierarchy, which is the finance department's hierarchy, because either one of them need to know about each other, and the lack of that connection causes, again, slowdown, a lot of emails exchange, and on and on. The last one I just want to talk about on the top right, Cisco has grown over time by assimilating a lot of companies. You bring in a company which is a moderate size, mid-size company, they have different product families, they have different subgroups. Now, getting the hierarchies into your native hierarchy takes a much longer time than being able to say, can I map them together? Again, it's a hierarchy mapping problem, which needs to happen. So next slide, please. Next. Yeah. So why did we pick Neo4j? There was the hierarchies, when you connect them, become well-connected graphs. And so the graph database had a natural semantic fit to that kind of problem representation. Next was the time variance I talked about. And then there was sandbox capability that you want to be able to say what-if analysis. What if I connected these two hierarchies in a different way? What is the outcome of that in terms of my reporting and data warehouse and so on? That means, again, a system that can not only see the past, because when you're going to do some changes, you've got to see whether this change was tried out in the past or not. So there's a time variance and being able to try out what you did in the past to something you want to do in the future. And then the approvals and all the stuff that goes with it is also part of the system. So, and then the business rules that go with it, you got to be able to validate each of those rules, whether you do it with a graph kind of a system using Cypher, that's what we're trying to do right now, or some other means. So the real piece of this is that at the end of the day, this all has to be real time. Your business analysts and business managers don't want to kind of wait for the next day for the computation to happen. Now, Neo fitted the bill as a part of a system. So what we have is a system built where Neo is one of the components, the heart of it, plus so many other things which are, think of it as assembled in Cisco model for using open source components. So next slide, please. So this is kind of a general sense of it. I just want to flash it and then skip through it. Basically what it does is the governance and single source of truth capability, one-stop shop for getting all the hierarchies, being able to model and so on. Go to the next one, please. So these are different open source components that are used. So the bottom you see the hierarchy engine. Then we are right now using a rules, which is open source rules based system, but eventually it get replaced by Cypher, because when this work started there was no Cypher behavior in the product. There's an open workflow, open symphony, and then there's Cytoscape is a visualization tool used in the molecular biology space. We adopted it for being able to visualize the hierarchies that this HMP system depicts. And then there's the internal Cisco software called CEPM, which is a role-based access that is very important for this kind of a system that runs mission important information. Go to the next slide, please. So here's the kind of example I wanted to show what we do with the Neo modeling for time variance. So what this shows here is the node org-A has a bunch of versions hanging out there based on time. We have time all the way to the second, though people don't do changes that fast. But you can go back to the old versions, the versions under N audit are some of the older versions. And this is what this causes is you have got to keep lots of information. Number of nodes and entities increase in very large numbers, and that this is where the SQL databases basically they fall apart because of the joins and the speed kills you. Like right now, there's only one hierarchy in there are two hierarchies which are connected at this point of time, and we already have 250,000 nodes and links in the system. And the forecast is in another year and a half to two, there will be about 3 million entities in the system. And then, so what you see here is the org-A and the org-C. Org-C has only one old-time copy. Org-A has 3 of these, and they are the way the APIs are built on top. They're all transparent. So you can go make a query to say, I want the hierarchy on this particular date, and it will make sure it can pick the right nodes and the links for that particular date validity. So it will figure out the date overlap and all that stuff. So it looks simple here, but the amount of information you need to keep is very significant there, and the traversals as well. Go to the next slide, please. This is just to kind of show, along with the time variance, there is a state diagram that you need to keep in place for the approval cycle. You can do what if as well as a live system all in one. That means you have to have states for everything, both the nodes and the links between different nodes, and the draft pending and approval cycle has to be captured and audited. So it has to be available to say who in the past made sure this particular hierarchy was finally approved and kind of stamped kind of thing. Go to the next slide, please. So this is the hierarchy mapping that I had verbally described before, that the top hierarchy is enterprise hierarchy, the bottom one is products and the product families that you have, and in the middle is where the problem lies. There was no, till we put this system in place, there was no way to do a revenue allocation by linking different nodes from one hierarchy to the other. And this information is not static, it changes over time, and sometimes even kind of time in the back, because there's some process most finance groups have called restatement, which has even more complexity of the changes that they do for the mapping between the two hierarchies. So where the system is today, this is a general purpose hierarchy management platform. It's not just meant for these two, but it's going to bring in HR hierarchies in there. It's going to bring in some of the supply chain forecasting hierarchies as well. And these are all would be available as a single source of truth for all the remaining ecosystem. I think I stop here. I already talked enough, and let you guys into the.
Okay, thanks, Prem. Yeah, I think you've answered pretty much all the questions.
Yeah.
But one thing I did want to ask, I mean, obviously, you found that graph databases was the solution for this problem. Had you tried to do it in any other technologies? How did you end up getting to that conclusion that it was a graph?
Absolutely good question. I forgot about that part. So when we started looking at this problem, we went out to shop for a system because typically IT will not build something from scratch. So we went to Oracle. Our standard vendor is Oracle, and they had a product called DRM. DRM comes from their Hyperion acquisition, and when we looked at it, okay, so you want a demo of it? Fine, they give you a demo which is very small. You can make a hierarchy. You can kind of have a good UI and all that. But we wanted to give them. We gave them real data. See, here's my set of hierarchies that I want to be interlinked or connected together, and the answer was no, I can't demo it. The system was really a very Mickey Mouse kind of entity. It never meant, it did not have the capability to take the scale of what Cisco required. The next thing we went to, I think there was a Hyperion has a product which is an MDM product which has hierarchy as a core part of it. So they could do some of these things, but every time you want to change, they have to go back, take a week, fine-tune the tables and the tuning and all that you do in a standard table-based system, and come back and show you. So the question was, what is your operational cost you're going to incur every time you do that kind of change? Plus, this is a real-time system. So the users, business users, once they get it, they want to actually be the guys in control instead of it being an IT in the loop. And at that point, we saw that there was a need to find out something else. And I don't know who came up with a new idea, but there was one of my team member basically said there was a graph option. So then we started exploring it. We ran some experiments with it, and it stood the scaling aspect very well. So right now our system actually runs on a 3-node high availability cluster, and it is also synchronizes well with the Cisco's policy of running on the cloud with multiple data centers. So there are 2 data centers, active, and all that stuff is going on. And so that because of its it being a newer kind of a system, it doesn't have the legacy of older databases where getting scalability is a hard thing. It has a horizontal scalability built for it.
Okay, thanks, Prem. Let's perhaps move on to Dominic for now, and then come back later on. But just if you could introduce yourself, the company you work for, and in particular, given the company you work for, the client that you've been involved with.
Yeah, I'm Dominic Wagenknecht from Accenture, so consulting and system integrator. I've been with Accenture for more than 5 years, and I'm a technology architect generally, so that just means it is my job to, whenever a client has a certain problem or brings out an RFP, it is my job to build together this landscape of IT components and also reason about why it is a smart choice to go this way or the other. I don't know who it is. And in this regard, I'm in NoSQL, so I'm trying to move forward the NoSQL space because also within Accenture we have seen that this is a future thing, and we see clients demanding solutions that require a level of flexibility that is hard to do with a relational database. And so I presented earlier a case of a global logistics company where essentially we brought the entire logical logistic network into Neo4j, which gives the client unparalleled flexibility. He can just move and change things. And there is this interesting point you mentioned that the functional people, so the people using the systems, they don't want to wait forever for the technical departments to get their things ready. And so we have stuff in there like flexible additional fields and all those comfort features, let's say, and they are pretty easy to implement in a database like for example, Neo4j. And it's just very lean and straightforward to make a new connection where there wasn't a connection before. Yeah, so that's what we are seeing.
Yeah, and I mean, from what I understand a little bit about the project, it involved the company thinking sort of differently about its network and how it moves things to be delivered through that network. So how did that translate to the technical solution that was delivered?
Well, in the end, logistics, and we see that in other cases as well. So we used Neo4j in a few other instances, but some materialized, some didn't. That this graph traversal is like the really key powerful thing. I like to use this corollary like with your friends network. If you're traveling through a logistics network, or you personally are trying to get from A to B, just imagine you're walking out there of the hotel and you want to go to Tokyo to some other hotel. So you will have quite a few hops depending on how your trade-off money versus comfort of ride and so on is. You will pick up a taxi, or you will even drive with a bus, and you will make a few stops, and then you will head over, and so on and so forth. So that is a typical graph job, and it is perfectly solved with graph traversals, whereas in a relational database you would have a pretty hard time, because in general you would have like two tables. The one would say these are the nodes, which is the bus stop, the airport, and some random locations, and then you would have the connections, which is like planes, buses, taxis, and whatsoever. And now, to calculate the way, you do like inner joining on this thing. So in this particular case, it makes absolute sense to go for a graph database. But I'm not saying that it's the cure of all problems.
Sure.
So we have multiple databases in the system.
Yeah, yeah. And in terms of the distribution company, I mean, the business problem they were trying to solve was about changing the way in which those connections were made. Is that
exactly.
correct?
So they wanted to be able to flexibly make connections between areas that were traditionally organized in different business entities and little kingdoms. Like many grown companies, you have an old structure, and at a certain point of time you want to break lines through that. And that is something that Neo4j in that case enables.
Sure. And so have you looked at other graph database technologies, or is it primarily Accenture working through Neo4j?
Given the point of time when we started that, we didn't really see a reasonable competitor at that point of time for exactly that kind of application. So, I mean, you have to do a trade. We are not big data, so we don't necessarily need stuff like Apache Giraffe or whatever. Java fits very well, so especially in the enterprise, I think running on Java is key. It's a very low entry barrier. It's also easy for the clients. All our clients use Java. They just have it. They have deals with Oracle or IBM to have their Java EE server. They just know how to run those things.
Sure.
Yeah.
Sure.
And we did a proof of concept, of course.
Sure. Okay.
Yeah.
And in terms of now the project obviously up and running, what benefits have you seen, both sort of technical and from a business perspective with that particular client?
Oh, that's very quick to answer. We're in the holiday high season and the system is running.
Right.
So there is no worse time for any logistics company than upcoming Christmas. It's madness. You can see that, for example, with Amazon. I mean, they are getting in temporary people by the thousands. But that automatically means that the entire global logistics system is pumping, because you have to get that stuff to Amazon. You have to get it to clients. It has to get to the suppliers and so on. So essentially, running up to Christmas, everything is full. Yeah.
Sure.
So when you're running steady at that point of time, it is sufficient achievement.
Okay. So I guess the big test, well, next few weeks still to come, but so far so good.
So far so good. Yeah. I mean, if we go till mid of December, it's then more or less typically the statistics tell us that then the wave goes down because the stocks are filled and so the pipelines are running out.
Okay, great. So Sebastian, last but by no means least, please introduce yourself, the company you're with, and the particular sort of problem you've addressed with Neo4j.
Yeah. So my name is Sebastian Hug. I work for Telenor, Norway. So we're a telco operator in Norway, major telco operator in Norway, so like AT&T maybe in the US. But our market is smaller, obviously. So in Norway it's around 5 million people, so and we have a major share of them. I work for within the mobile department, so the mobile subscriptions. Yeah, so we actually had a problem then. It was we have administrators of large companies who are customers of Telenor, and they have a lot of mobile subscriptions. So we have a self-service solution where they can enter and do changes to all the subscriptions, look at accounting parts, everything. And because it's important, very important to maintain security. So when the administrator logs on, we need to address which resources within the company is he allowed to access. That's really, really important, as you understand. And previously, I mean, when we had like smaller companies and when the usage of mobile subscriptions took off and they bought more and more, and the problem was that calculating this, which resources you have access to within a relational database, as we did, took more and more time. And for our largest customers having maybe 100,000 subscriptions, that took up to 20 minutes. So the solution would be that during nighttime, we would log on for the user, calculate all the resources he had access to, and cache it. Yeah. So, yeah. And then, I mean, that was one thing. So the caching worked, but you had stale data. And if you had a new user, like create a new administrator for a company, it will still take, for the large customers, like up to 20 minutes for the new users to gain access to the resources and be able to log on during daytime. So, I mean, that was the problem. And it was basically, we need to find a way of doing this much, much faster. So we did a little investigation. We tried to look at different kind of technologies. We thought about doing like an in-memory version of the relational database. That was one option. We thought about using a graph database, because the way that we give access to a user is, for large companies, it's simple as he's given access to a top node, and that top node being the legal entity of the company. And that company might consist of other legal entities, like companies that are owned by the parent companies. So we have a structure already. We're seeing the structure, so you see where I'm going here. And within those companies, you have a lot of accounts for billing purposes. And below the accounts, obviously, then you have the subscriptions, all the subscriptions. So all of these resources are connected in a thread structure. And that's why somebody said, hey, look at the whiteboard. This looks like a graph. Maybe we should use a graph database. And I mean, we didn't have time to evaluate a lot of different options. So we did a little research around the market, which are the leading providers for graph databases. And we found Neo4j to being a good candidate. Many people used it. So we said, okay, we start prototyping really early. So we started prototyping, and it seemed to be a good match. And then we made a decision that okay, we could do this in-memory relational database stuff, but what do we believe in? We didn't have really the money to and the time to try both solutions. So we said, okay, we believe in the graph database being the optimal option. So we just went for it from there. Yeah.
Okay. And what are the results? I mean, so you said it was previously 20 minutes to run that. What are you looking at?
So I mean, the project, so the resource authorization service that we now introduced using the graph database, which replaced the old one being installed procedures within the relational database. It took up to 20 minutes previously, and now when we do it within the graph database, we have extracted a subset of the data within the relational database into the graph database. We have everything within heap. So in terms of heap, we're about 15 gigabytes, the heap size we have, because we have shaved away everything else that's not like structure. So we only have the structured data within the graph database. And calculating now for the worst case now for calculating for big customers, so that's 2 seconds. So it's a huge improvement. And even, we don't even more like, it's not normally that we try to calculate all the resources. That's something we did previously because we cached it. Now we actually just check, do I have access to this resource, right? And doing that within the in the graph database, that's 2 milliseconds. That's even faster. And that's like, you have one user, you have one resource within the entire, like all the users, you have like many million users and tens of millions of resources. Is there a connection between them? And we also have like business rules regarding, you have to see if you have inheritance allowed for this resource because not all users have that. So we also have some logic you have to compute, and that's 2 milliseconds like for just picking 2 nodes in the graph database.
Sure.
So I'm just wondering, like, in your guys' organizations, the people who have like the grand vision about how the enterprise is going to use these kinds of technologies, they're talking in terms of milliseconds and caching and database choices, or is it something else that's driving, the adoption of these technologies in the enterprise?
I think most important thing is, are you solving a business problem or not? So business would hardly care whether you use Neo or you use Oracle or MySQL, but fundamentally, what offer can the IT give in terms of the vision that these are the class of things that business can do differently?
So can you guys maybe speak to what those demands sound like? I mean, like, what are the business goals? Like, how are they expressed when around these kinds of things? I mean, how is the value kind of like presented to the technical team to execute?
Speed of how fast business can do things themselves. I think the biggest thing most IT is infamous for is IT takes time, IT takes money. Business says, no, I'd rather give me something that I can use myself for changing whatever I'm doing in the application. And I think we're going towards that direction. The more you have systems which have lower cost of operation and the lower cost of change. Business is not static. It evolves continuously. And that part IT has not really kept up the speed with. I think so it's not just the fact that you're trying to use Neo to solve all the problems. Neo is one part of the answer. It has to be the whole set of application domain has to think differently. And this is what we have started doing now.
Sure. I mean, this was a question that cropped up early in my presentation in terms of, if you start trying to talk to the business, particularly if you're trying to get, the funding for the project, and you start talking about graph databases, graph models, they're probably going to quickly sort of the eyes glass over. So it sounds like the key thing is to pinpoint, if you can, the business benefit that will come from the graph database, graph models, and start to talk at that level, and you focus on the actual technical issues yourselves.
In fact, most companies, the MDM initiatives fail. If you go to the Gartner stats, it is almost like 60% plus fail. And the reason they fail, one of the reasons is that it is always pushed as an IT initiative. We did very different stuff with MDM. The other two that I described as well, and including hierarchy management, that we took the business problems and we tied business ROI to say, now if you do this funding for this MDM initiative and how it is helping you really solve the real end business ROIs, then the story is very different. Business wants to work with you, and the change management that goes with it is also not an issue for business if there's a complete story to that.
Sure. Other research analyst companies are available, of course. Question over there.
So it looks like you all use this technology as an extension to your existing IT infrastructure, not as a replacement. So what's your experience with pushing data from one system to the other? To synchronize data between the database and the graph store?
I think the key about managing your data is having a clear sense of who has the ownership. So which one is the master? In the case I presented, we replaced the master. So the old master is essentially now just updated daily via push. In Neo4j, going more to the technical observation, pushing data into Neo4j. So if Neo4j is like the recipient, and it is like the add-on system where you do your complicated graph things or your analytics or stuff like that, you would simply run a batch insert. That one is pretty performant. Don't try a normal one. Getting data of Neo4j out, in our experience, is not a problem at all. So read performance on Neo is really good. We typically have the problem that the JDBC connection on the other side can't handle the incoming load. So it's pretty straightforward, although there is no support within Neo4j for some kind of batch execution or ETL or something like that. That's so. Yeah, you got to do that yourself.
So I could just follow up that one, because we had a little different approach there. So I think it's worth noting. I mean, we have it's a legacy system. It's a 12-year-old middleware system, monolithical, and also we have like one large relational database with everything. So there was no real option replacing the relational database with a graph database. So just to tell quickly, I mean, this is also a benefit. Like we basically, from our relational database, we have a feed of messages. So, and this feed is updating live the graph database. So we do that continuously. So if I do a update or insert within the relational database, within milliseconds, the graph database and the services are updated. So that's great. And also, I mean, for our part, that was also essential in order to reduce risk. Because if we were to take a critical component of data mastering and replacing that with new technology, there would be a lot of risk. And this way we had this service, which was then fed on replicated data, and we reduced a lot of risk just by doing that. And also, that being a simple way or a simpler way to get acceptance within an established organization to use new technology. If we would try to resell or try to sell new technology and say we're going to replace, then it would be a much harder sale also. So I think it's a good approach in order to take advantage of new technology.
One of the things that I talked about earlier was, if you look at the graph database landscape, one of the ways of dividing that up is between, kind of graph compute engines, which can run on, relational database or Hadoop or whatever, versus, true graph databases with native graph storage model as well as graph processing. And one of the questions I had afterwards was, if you can do graph processing on a relational data store and your data is already in a relational database, then why would you move to a graph, a true graph database like Neo4j? I mean, is that something that you had considered, or what's your perspective on that? What are the benefits of moving specifically to graph storage plus graph processing rather than graph processing on a relational database?
So I can say that there's like two things. One thing is whatever you try to solve, try to isolate it. So putting everything within a relational database, that's stupid. Okay, so we had one very clear objective, one service, and we applied the technology that matched that service. So if that's relational database or if graph database or whatever, that doesn't matter. You have to find the technology that actually suits your purpose. So that's important. So I mean, we use graph database, and that's good for this special service. But for other services, we just rely on relational database because they will be best for other services. So we have to evaluate what kind of query, what kind of we want to do. And the other part being that I didn't say about the graph database, because that's important. Our previous store procedure, which did a resource calculation, that was 1,500 lines of SQL, okay? And now we do the same logic is represented within one class, like, yeah, some tens of lines to represent the same, because the kind of query we express with doing a traversal is very simple to do within the language of a graph database, and it's much more complex to express within a relational database. So that's a huge benefit, simplicity.
Okay, another question over here.
So, about your specific scenario, you said that you have a relational database, and then you're streaming the data from the database to the graph database, and then you do analysis in the graph database, right?
Yeah, like we do the queries right to.
Isn't there some sort of redundancy going on there? Because I don't know what graph database do you use, right? But if you use Neo4j for that, for example, and they provide their own, as you said, their own native storage model, their own transactional processing, their own asset property management. So you really need that? Is it like another layer of reliability, or it's just introduces an extra overhead that could be dispensed with, and you just had an in-memory graph analysis engine that does not actually have any of these things. It just has an interface for you to send the queries, right? And in fact, all the reliability, consistency, and all this storage-related things would be managed by the relational store. Wouldn't that be a more optimal solution?
So just cut short, I mean, our system is now eventually consistent, so that's important, because we don't have transaction between relational database and graph database. So we have to accept that and handle that if that's a problem. The other part being that you need to be able to store within the graph database, because if the server goes down, something ends up again. The initial population takes hours, okay? So if we had everything within memory and it went down and we had to populate it again, that would take too long time. So we need some kind of storage. Not maybe ACID, but we need storage in some way, yeah.
Okay. And obviously you've talked about the current implementations, but one of the things we've seen, once people start using graph database technologies and start thinking in a graph way, that they immediately start to see other projects and other possibilities for those. Where do you see the potential opportunities within the companies for further use of graph databases?
I think I can see a lot here. The network companies or the network management is one very ripe area for that, and there's some experimenting going on in that space with Neo4j. And it's really a large number of nodes and large number of interconnection and the business rules that need to be enforced. And it's the kind of right thing that can be used. Other area we are trying to look at is we have a content management problem in the company as well. And that's a new role I'm taking in the next few days, which is fundamentally how do you find information among so many different content stores that you have? These are unstructured storage information, which is the old documentum stores, and the engineering has its own custom store. Then there's a video, then there's a WebEx transcripts, and on and on and on. Now, there's a really wealth of information out there, but it is not easy to find it. Is there a option to use something in a combination of graph database and potentially Hadoop kind of a processing to make their life easier so the search engines can do a better job? One question we keep getting is, Google does such a great search, how come your internal search is lousy? And there's a problem with every large company, because what Google is able to do with the kind of feedback it can get on its algorithms, we can't do that unless you have the metadata that can characterize the content that you are trying to index. So there's a big ripe area that we see for this kind of work.
No, not specifically about the case I was talking about previously, but we are discussing a lot within our technology architect community, and because people come from different projects and they have seen different problem situations, and there is a wide space where this can go forward. So we see especially problems around CRM when they get a little bit more complicated. They are very graphy in nature and hard to deal with. We analyzed a few cases in financial services where you have very complex dependencies between products and risk classifications and stuff like that. So there are quite a few problems out there that lend very, very well to the graphical model, and it adds value if you do it like that. It's like I thought the previous discussion about replacing a system completely by a new one, you only do that if that adds value of some kind. And I mean, that's the important thing really about it. So the new system needs to answer questions you couldn't answer previously, or you could only answer in an unsatisfactory way. Like 20 minutes is not satisfactory. But there is a wide range of things.
Sure. Yeah, so I mean, I don't know I actually don't know other areas within our company where we could benefit from using a graph database. But since we are a telco company, I would be amazed if there weren't other areas where we could use it. So what I see is a problem that, at least in our organization, being that the people knowing about the business problems don't know about the technology that might help them. So when I try to talk about graph databases within our company, people, they just stare at me and what are you talking about? They haven't heard about it. If I try to say NoSQL, it's like, what's that? So there's especially amongst the people who may make the decisions, like architects or other people who actually are able to say that we're going to use, the people who decide if you're going to use new technology, they don't know enough about the technologies that's out there. They're just used to doing stuff the usual way, using a relational database and everything. And that's the hugest problem. We have to try to get more competence within our organization, at least, in order to take use of all these new technologies when they are applicable and will solve a business problem.
All three of you have experience with relational technologies and graph technologies. So the question to you would be, for the graph technologies, in order to address that problem right there, to increase the adoption, what are the technology features or capabilities you would like to see that would help you solve your graph problems become now even better, or to improve the adoption of the incorporation of graph technology into the IT environment, given the legacy relational orientation there? I'd be curious to get your experience.
Yeah, I can give you the answer from the Cisco perspective. So one thing that that happens in the infrastructure folks who kind of who deploy the solutions is that from Oracle they're used to lots of tools and dashboards and what have you for the database health and keeping it up and all the stats that comes. Neo needs few things to be added. Neo is much simpler, but it doesn't mean that it can escape that whole piece of how to operate the system. And right now, I think there's a JMX interface, but you need a good JMX receiver where you can tie all the things that Neo throws at you when it's operating. And we did not find in our IT a good JMX console for whatever historic reason. So that's one area. I think the bigger question that I think that is about SQL versus why Neo at all. There's a lot of the past experience people have with SQL, which is good, So it's not to replace SQL, but to kind of educate what is the right solution for a right problem. That's the key thing. You're not trying to replace SQL with NoSQL. You're trying to get the right problem. So that education is a thing that needs to happen. The size of the problem, the connectivity of the problem. I think the three things that were heard this morning, Eric's lecture was on the modeling, and there was one thing that he mentioned that stuck with me was when you're modeling, don't throw in extra stuff into it. Model for what the problem you're solving. I think that's where Neo fits in well, and even SQL will fit in well. It's just that's a style of solving a problem in a most elegant way. And the second is the total size. How fast will your data grow such that your performance doesn't degrade over the expected life of the application?
Okay. Dominic, Sebastian, you got any key things you'd be looking for in terms of the future development?
I see it quite similarly, but an important point to make is there is industry take-up. So the product itself must be kind of good. Quite simply. But I'm completely with Prem that we still see that a lot of things on this enterprise-ready checklist are still missing. That goes from user rights management, it goes very much into the operations area. So there needs to be like this ecosystem readiness that still needs to be completed. And also with the monitoring, for example, that is a prime example. You won't get for the big monitoring systems from BMC and so on, you don't have a Neo4j plugin. It just didn't exist. So we, in our case, invested a lot of time into building our own adapters to the JMX endpoint. So we exported the JMX in a format that the monitoring system from HP could read, so that the operations people were even able to drive the system. So the system is fine. We know the limitations. Right now, we know it is not scaling horizontally, but I mean, most data sizes I have seen fit nicely on a machine. Big data is, of course, a big hype, or a big topic, but not everyone has big data.
Sure. I think one quick question here with regards to that quickly, and then that's all we've got time for, I'm afraid. But
so all of you talk about property graphs, right? Node edges with Q-value pairs, basically. Have you ever considered the W3C standard RDF graph? What are your thoughts on that?
so yeah, that's a
complex reasoning about.
Yeah, the question was about, obviously they were using Neo4j property graph and whether they had considered RDF semantic graph technology for that, that's opening up a whole new panel, I think. But
yeah.
Briefly, yes or no, and if not, why not?
Yes, because we have enough people that did a PhD and believe in the semantic web and all those topics. But in the end, you should deliver a system that is as simple as possible. And frankly, nodes and relationships with an attached hash map bring you pretty far. So it was sufficient in our case. We don't have a hypergraph. We just don't.
Any other comments on there?
We just tried to evaluate the market and went for Neo4j. So that's the way we did it. Prototyped, did it work? Well, yes. So we went for it. As simple as that.
Okay, great. Well, we're already, I think, over time, and I'll let you get on to the next break. But please join me in thanking the panelists.